Continuing with our study of direct variation, today we're going to be focusing on making a connection from a table to an equation. And if you remember, yesterday we made a connection from a table to a graph, and from a graph back to a table. As we look at this example here, we're supposed to identify a pattern or find a constant from the table. And what I notice is to get from my 2 to my 6, or from my x to my y, I multiply by 3. Looking at the next row, 4 times 3 gives me 12. 6 times 3 gives me 18. 8 times 3 gives me 24. See, I notice that that's a pattern and that it's happening every single time, so we call that a constant. In direct variation, there is a specific equation that follows along, and that is y equals kx. Now the k has a special meaning, and the k stands for the constant of proportionality. Notice that I highlighted the word constant because that was the same word that I noticed a slide prior where I said the constant was 3. Now I'm saying that the constant will be in the place of the letter K. So as I go back to that table where I have 2 and 6, 4 and 12, 6 and 18, and 8 and 24, I'm going to try to figure out the equation. So if my constant was 3, then using the equation y equals kx, my constant will get plugged in. Instead of k, I will use the number 3 to create the equation y equals 3x. Let's look at this next example. In this example, to get from 3 to 6, I can multiply by 2. From 6 to 12, I can multiply by 2. From 9 to 18, I can multiply by 2. And from 12 to 24, I can multiply by 2. Therefore, I would say that the constant equals 2. Well, there's another way that I can look at this. And this other way I can look at it is I can take my y value and I can divide it by my x value. I want you to take a look at this. If I divide, in the first example, my y, which is 6, by my x, which is 3, I end up with 2. Now, this 2 was the same number that I came up with for my constant over here. Just to make sure you don't think that's just a coincidence, I'm going to work out all the rest of them. Notice that as I divided every y value by its x value, I ended up with the same constant, which was a 2. Now that I've figured out what the constant is, I'm going to write the direct variation equation with my constant of 2 in the place of k. Let's take a look at this example. Now, as I look at my x and my y values, I notice that I'm not able to multiply 5 times something to give me a 1. I don't know what I can multiply 10 times to give me a 2, or 15 times to give me a 3, or 20 times to give me a 4. I don't know what that number is supposed to be just by looking at this table. So in this case, I need to use the shortcut or the other method of dividing y by x. When I divide, in the first example, when I divide 1 by x, I have 1 divided by 5, or y divided by x is 1 divided by 5. Well, there's no reason for me to actually divide because it's a proper fraction, so 1/5 is what I get for my constant. Well, let's just check to make sure that it works for all of them. For the rest of the table, I went through and put y over x. And in all three of the rest of the rows, after I did y over x, I still need to simplify those fractions. And when I simplify, I end up with 1/5 for each of them. We're going to now go from we're going to use the direct variation equation, which is y equals kx. And we're going to plug in the value that we got, the constant that we got, which was y equals 1/5 x. And so that is my direct variation equation, y equals 1/5 x. Next, we're going to move on to a different approach. Instead of going from a table to an equation, we're going to go from an equation back to a table. I'm going to take my k value, which is 8, and I'm going to turn it into a fraction. Now, I know that 8 is not a fraction already, but I'm going to turn it into the fraction y over x. Now, to change a whole number to a fraction, all I have to do is put it over a 1. So now I know that my y is going to be 8 and my x is going to be 1. And that's what we see down here in the table already that I've started for us, is that y is 8 and x is 1. From this point on, we are just going to simply take that same fraction, 8 over 1, and we're going to find equivalent fractions to fill up the rest of the table. Now my y is 16 and my x is 2. And you can see that I have finished finding equivalent fractions, and I have plugged those values into my table. Another example, y equals 1x. Since 1 is a whole number, I need to make it a fraction, so I'm going to put it over 1 so that I can use y over x. My y is going to be a 1, and my x is going to be a 1 inside the table. And I will now find 3 more equivalent fractions.
Like I'm now using school-wide announcements to bring your spelling.
And in our final example, we're going to go from 1/4, which is our constant, which is already in fraction form. I'm going to use y over x. So my numerator here is already my y, and my denominator is my x. And as I use other equivalent fractions, I will turn 1/4 into 2/8, 1/4 into 3/12, and 1/4 into 4/16.